So let's solve an example, one example. So we have the system of 3, 4x plus 2y plus 3z equals 12, 2x minus 3y plus 5z equals negative 7, and 6x minus y plus 4z equals negative 3. The very first thing that you need to do is, other than this step 1, is you need to choose which variable you're going to eliminate. So let's take a look at it. So I have x's, y's, and z's. Now I like to choose ones that have an isolated variable or a variable that only has 1 in the coefficient position. So for example here, that only has a negative y, which is nice. That means I could manipulate that easily to be a 2 and a 3. You want to evaluate the values that you choose or the variable you choose, because if you happen to choose a variable just for the sake of choosing it because you like a letter or you don't want to think about it, it could be harder to do. So for example, if you decided to choose z in this case, in order to make that work, I'm going to have to multiply 2 equations each time to try and eliminate the z's. So the z's in this case is probably the one that you don't want to do because it makes it harder because number 1, you have to multiply 2 equations. You're more apt to make some small minor mistakes. And then the numbers get really large, which makes it really hard to deal with sometimes. So try to pick numbers that are smaller, maybe picking ones that have, for example, like in this equation where there's a negative, just a coefficient of 1. Or you can always pick one where they have the same exact coefficient, okay? X's would be okay here. But we'll see that in our next example. So we're going to go ahead and choose y in this case. Let's choose the variable y. And some things to remember is that when we choose that variable y, we must eliminate the same variable. So once I pick 2 equations to eliminate the y value, I need to eliminate the y value again. So this case, we're going to eliminate y. It's not always the case, but in this case it is a y. The other thing you must do is you must use all 3 equations at least once. Okay, you must use all 3 equations at least once. So let's eliminate our y's. Let's start with equation 1. So I put a little mark to say I'm using equation 1. So that's 2y. And so I'm going to use that. The best one to use that with is equation 3. So I'm using 1 and 3 first. So this is negative y, and I have a 2y. So what do I need this y here to be? I need that to be negative 2y. So how am I going to change it? Well, I can multiply this by a positive 2. So let's multiply. Make sure you distribute. This is 12x minus 2y plus 8z equals negative 6. And again, I'm multiplying by a positive 2 in this case. Okay. So then I'm going to write my equation 1 below it, 4x plus 2y plus 3z equals 12. So I'm going to add them together. I get 16x plus 11z equals positive 6. So this is my new equation 1. So the next thing is I did use equation 1 and 3. So my next step after that is I have to use equation 2. So it doesn't matter what I do, but I know for sure I have to use equation 2. And which equation 2, so I'm going to add equation 2 with another equation. Which one does that work with better? The first one or the second one? Again, I'm trying to eliminate my y's. In this case, I want to go ahead and multiply this bottom equation. I need my y's to be 3's. Okay, so this is a negative 3y, therefore this needs to be a positive 3y. So how do I change this negative y to a positive 3y? Well, I need to multiply that by a negative 3. So multiplying that together, I get negative 18x plus 3y minus 12z equals a positive 9. So that's my new equation 3. I just manipulated it. Now I need to use equation 2, so I'll write it below it. 2x minus 3y plus 5z equals negative 7. Then I add them together. My y's cancel, so I get negative 16x minus 7z equals 2. So this is my new equation 2. So now that I brought them down to a system of 2 variables, I'm going to see if I can add them together so I can solve for x and z. This is a nice case because notice if I add them together as they are, my x's will cancel. So this one is a nice one. So let's go ahead and add new equation 1 to equation 2. So negative 16x minus 7z equals 2. Add that together. Our x's cancel. So I get 4z equals 6 plus 2, which is 8, divided by 4. So I know that z equals 2. So now that I know z is 2, what I want to do is find my x. So I don't want to go back to the beginning yet. I still need to solve for this other variable. So I'm going to take this 2 and plug it into one of the equations. So I'll plug it into here. So negative 16x minus 7 times 2 equals 2. Then I solve. So negative 16x minus 14 equals 2. Add 14 to both sides. Get negative 16x plus equals 16. Negative 16x equals 16. Then divide by negative 16. Then I see that x equals negative 1. So now that I have those two solved, now I can plug it into my original. So substitute into an original equation and solve for y. So once I have 2 variables solved, then I go back and substitute into one of these 3 variable systems, 3 variable linear equations. So I will plug it in to the bottom one. So this is going to be 6 times our x is negative 1. And then minus y, that's what I'm solving for, plus 4 times our z value, which is 2. And that all equals negative 3. So we'll solve. This is negative 6 minus y plus 8 equals negative 3. Negative 6 plus 8 is a positive 2 minus y equals negative 3. Subtract 2. Negative y equals negative 5. And I can't leave it negative, so I divide by a negative to get rid of it. So y equals a positive 5. The thing I need to remember is writing it as an ordered triple. It has to be in order. So x is negative 1, y is 5, and z is 2. And this is done. And you could check it by plugging it in into all 3 if you have time. So I hope this helps out. I'm going to do extra example below in the next video. Thanks for watching.